All right, the second question. Find the z-transform and the region of convergency for this sequence. Okay, what we're gonna do for this one is we can make this one function and this one another function. So yn, we will say that yn equals to x1n plus a x2n, and we make x1n equals to a to the order of n un. This one we very familiar with, and we can say that x2n equals to negative bn u to the u negative n minus 1. Okay, that's another part. And if we do a z-transform of this one, we got capital X1 z of z equals to, that's what we familiar with. We just did that in the first question, 1 minus a z. So this is also from the table as well. And there is ROC, which is this z has to be larger than a, the magnitude of a. Okay, and another one, if we do a z transform of the second one, so this capital Fx2 of z equals to 1 over 1 minus b 1 over 1 minus b z to the order of negative 1. Okay, why, I will explain that later. Okay, ROC, just give you the answer here. Z is smaller than b magnitude. Okay, that's for x2n, this one. I know it's a bit confusing if you do this. I will explain that later. Now let's just accept this true. If this one do z transform is this, and this one do z transform is this, so the total thing, that's capital YZ, just equals to you add them together, 1 minus a multiply z negative 1 plus 1 over 1 minus b z negative 1. Okay, and there are ROC, right? We need to talk about ROC. So if the number b is larger than a, which is okay, which is good, because this one has to be larger than this and has to be smaller than b. So if b larger than a, that's good. So z is just sitting in between. Okay, z is larger, smaller than b but larger than a. So if we draw that, it's something like if this is a and this is a b, then sorry about my drawing. So the region of convergency, if that is a, so region of convergency is this area. Okay, is this area. This shape called an annulus. Okay, this kind of shape. But if b is smaller than a, then z has to be bigger than this but smaller than this, which is the ROC not exist. Okay, it's just not exist. Right, so that's the whole solution of this question. Now let's look at this x2. Okay, this bit is a bit confusing how you got that one. They look so different, but you got a pretty similar z, right? But you can see that the ROC is much different. So let's prove that. So in this part, we got this question, 2n x2n equals to negative b to the order of n. The unit function is negative n minus 1. Okay, so how we solve that? Like always, we gonna put it into a definition like this. Okay, so it's n start with negative infinite to positive infinite, and then we got put this thing in u negative n minus 1, and don't forget z multiply z to the order of negative n. Okay, so that's this part. Then we start to making plugins, right? So this one's not regular thing, so we're gonna make this m equal to negative n minus 1. So n gonna equals to negative 1 minus m. All right, so negative n just equals to positive 1 plus m. Okay, so we start to plug in numbers. So this one becomes n to the negative this one, and b, we just replace b with a negative m plus 1. Okay, and this u just become um, and z to the order of a negative n, so is 1 plus m. Right, so that's what we got. And yep, so don't forget about this. So I just replace this replace this n with a m, because it's just from infinite to negative infinite. So we can make this one equal to 0, because this one and to positive, and we just break this one. It's become negative b negative m multiplied with b negative 1. Okay, and then this one's gone, is z multiplied with a 1 and multiply with a z to the order of m. Okay, so we're gonna bring everything which is not related to m out. This one's not, so is z over, this one's b on the denominator, and the negative sign is not very useful as well, so I just is not related to m, so we bring it out, and then we got this sum. Inside of it is b negative m z m. Okay, and we can start to extend that. We can start to just look at this part. Okay, look at this part. So what is this? So this part equals to, we extend it, m equal to 0, everything equal to 1. M equal to 1, then we got, because this is negative 1, right? We got a z over a b, just 1, order is 1, right? And 1 m equal to 2, then we got a z over b 2 all the way to z over b to the order of m. Okay, then when z over b, the magnitude is smaller than 1, right? We wanted this thing smaller than 1, and when n approaches to 0, it converges, right? This geometric series, we talk about that. So the whole thing, the red thing, gonna equals to, the red thing gonna equals to 1 over 1 minus that over b. Okay, so only when this happens, this one is the result. And then let me scroll down, then let's keep going back. So we combine that, so zb multiplied with 1 over 1 minus that over b, we got 1 over 1 minus b z to the order negative 1, and have ROC, which is z is smaller than b. Okay, Z smaller than B. That's what we got, right? Exactly the same thing. Yeah. All good. So that is question number 2.